So welcome back. Let's look at dividing by 10. So another thing to think about, dividing by 10 is really like multiplying by 1/10. Just like taking half of something means to divide by 2, multiplying by 1/10 kind of means to divide by 10. So multiplying by 10, or multiplying by 1/10, kind of implies losing a decimal place. So, because when you divide by 10, you're actually going to get smaller. So if I look at 8 divided by 10, we can look at this as 8 divided by 10, or in other words, 8 times 1/10. And what we learn is dividing by 10, or multiplying by 1/10, essentially means you're going to lose a decimal place. So remember, on the whole number, your decimal place is here. You're actually going to lose ground. Your decimal is going to slide over to the left. So therefore, your answer is going to be 0.8 or 8/10. So that should match up. 8/10 is 8/10. So 8 divided by 10 is like losing a decimal place. So 9 divided by 10 divided by 10, that's the same thing as 9 times 1/10 times 1/10. So what this essentially means is if you multiply by 1/10, you're going to lose a decimal place. If you multiply by a tenth again, you're going to lose another decimal place. So in other words, your decimal has to slide over from this spot 1, 2. And I've got to use 0 as a placeholder here. So that answer ends up being then 0.09. Or in other words, 900ths would be your answer. And you kind of see that 900ths there in that problem. But as a decimal, it would be 900ths. So if we look at this problem, I have 600 divided by 1,000. That's the same thing as 600 divided by a 10 divided by a 10 divided by a 10. Since there's 3 zeros there, that means you've got 3 tens there. So in other words, this could also mean 6 times 10 times 10 times 1/10 times 1/10 times 1/10. What we learned in math is multiplying by 10 and dividing by 10 are inverse operations, so that 10 really just eliminates that multiplying by 1/10. This 10 here essentially eliminates multiplying by that 1/10. So all we really have left is 6 times 1/10. And multiplying by 1/10 kind of implies moving the decimal one place to the left. So on the 6 here, that decimal is actually going to slide over to the other side of it. So that answer is going to end up being 6/10, 0.6. So again, divided by 1,000 is essentially like moving the decimal 3 places to the left. 1, 2, 3, and that gets you back to that same spot. So a couple ways to see that. Now let's look at some decimal numbers. 2.5. You know, I could throw the decimal out and write this as 25, but 25 is not the same thing as 2.5. But since I gained a decimal place, I can offset that by multiplying by 1/10, which would make me lose a decimal place. So 25 times 1/10 is the same thing as 2.5 because multiplying by 1/10 means to slide the decimal back over one spot. So those are equivalent. So 3.75 is the same thing as 375. But notice how I'm sliding the decimal over here. To offset that, if you multiply by 1/10 and multiply by 1/10, these would be equivalent because multiplying by 1/10 would mean to slide over 1. Multiplying by 1/10 again would put it right back where it was. So these two represent the same thing. So I can change 3 and 75 to 375 times 1/10 times 1/10. So when it comes to this problem here, 8/10 times 2/10, I can look at this as 8 times 1/10. And I can look at this as 2 times 1/10. Because again, that multiplied by 1/10 means you're back to 8/10. Multiplied by 1/10 brings that back to 2/10. But notice how this is all multiplication. In a multiplication problem, order does not matter. I could change this to 8 times 2 times 1/10 times 1/10. In other words, I would have 16 times 1/10 times 1/10. But remember, when you multiply by a 10th, that essentially makes your decimal move over a spot. But if you multiply by 1/10 again, you have to move it over again. So that ends up being then 0.16. So as a shortcut, what we can pick up on is when you multiply decimals, essentially what you can do is leave the decimal out. So if I just take the decimal out, you should see I just have 8 times 2 is 16. But notice how there's 2 numbers behind the decimal. So it kind of tells me to slide that decimal 2 places to the left to get that answer. So that's kind of our thinking. So when I look at this problem right here, if I want, I can look at this as 12 times 7. And I can write that as 84. But notice how the decimals still got 1 number there behind the decimal and 2 numbers there behind the decimal. So notice that I've actually removed 3 decimal spots. I still got to put those 3 decimal spots back in the answer. So to put those 3 decimal spots back in the answer, what this is telling me I can do is slide the decimal over 1, 2, 3, and that would give me 0.084. So that's kind of our shortcut to multiplying decimals, is you can kind of leave the decimal out and then multiply and then stick the decimal back in because of this concept here that we are allowed to pull that 1/10 out and put it at the end. Okay, so I hope that gives you a little bit of insight of why dividing by 10 and multiplying by 1/10 are so powerful. It can kind of really play with some decimal numbers especially. So stay tuned.